Hello students, today we are going to solve the problems which are based on displacement, velocity, acceleration, Newton's laws of motion and equations of motion. Some steps are to be remembered when we solve the problems. First step is read the problem very carefully. Enlist the given parameters. Convert these parameters into similar unit system, means either in SI unit system or CGS unit system if necessary. Select the proper formula. Substitute the known parameters or given parameters and calculate unknown parameter. And last one is write the final result with proper unit. So remember these steps when we solve the problems. First problem. A truck travels north at a constant speed on a straight north-south, covering a distance of 25 km in 30 minutes. The driver realizes that he forget to pick up a package and turns the truck around and heads straight back to the original place. It took him 20 minutes on the return trip. Find the displacement, average speed and average velocity for the entire trip. Entire trip means truck starts from north to south and south to north. So it completes one trip. The given parameters are x1 is equal to 25 km, t1 is equal to 30 minutes, then x2 is equal to again 25 km and t2 is 20 minutes. So we have to find out displacement, average speed and average velocity for the entire trip. We know that the displacement for the entire trip is equal to x2 minus x1. That means x1 is north to south distance while x2 is south to north distance. They are equal in magnitude but opposite in direction. So we consider negative sign. So displacement for entire trip is x2 minus x1, that is 25 minus 25, which is equal to 0. Then average speed is equal to total distance by total time. Total distance is equal to x1 plus x2 and total time is t1 plus t2. So we know values of x1, x2, t1, t2. Substitute here. We get 25 plus 25 by 30 plus 20, which is equal to 50 by 50 kilometer per minute. Convert this minute into hour. That means we have to divide 50 minutes by 60 and 60 goes to numerator. So we get 50 by 50 into 60 kilometer per hour. 50 get cancelled and average speed is 60 kilometer per hour. Then third one is average velocity. Average velocity is defined as the ratio of total displacement by total time. But total displacement is 0. In first point, total displacement is equal to 0. So we get average velocity is equal to 0 by 50. That is equal to 0. So in this way, we have displacement, average speed, average velocity for the entire trip. Second problem. A train is traveling due east at an average speed of 120 km per hour. How far does this train in 5 seconds? So first of all, we have to write down given parameters. So average speed is given, which is equal to 120 km per hour. Convert this kilometer into meter and hour into second, which is equal to 120 into 1000 by 60 into 60 meter per second. Then time t is given 5 seconds, and we have to find out the value of how far, means we have to find out distance. So write down the formula. Average speed is equal to total distance by total time. So rearrange this, we get total distance is equal to average speed into total time. Putting value of average speed and total time, that is equal to 120 into 1000 by 60 into 60 into 5. By solving this, we get distance is equal to 0.1665 into 10 raised to 3 or 166.5 meter. Then third problem. Two cars A and B starting from the same point, moving with average speeds 50 meter per second and 45 meter per second. What will be the separation between two cars at 15 seconds? So the given parameters are speed of car A is given, that is 50 meter per second. Speed of car B is given, that is 45 meter per second. So separation between car A and B is 5 meter per second. 50 meter per second minus 45 meter per second, that is 5 meter per second. So meaning of 5 meter per second is in 1 second separation will be 5 meter. So we get the separation between average speed of car A and B is 5 meter per second. And we have to find out separation for 15 seconds. So separation between two cars at 15 seconds is equal to 15 by 5 upon 1, which is equal to 75 meter. Hence the separation between two cars at 15 seconds is equal to 75 meter. Fourth problem. A body of mass 25,000 gram is acted upon by a force of 5 Newton. Find acceleration of the body in SI unit system. So first write down the given parameters. A body of mass means m is given, but m is given in gram. Convert this gram into kilogram. So we get 25 kilogram. Force F is equal to 5 Newton, and we have to find out A, that is acceleration. So we have to use Newton's second law, mathematical relation for second law of motion, that is F is equal to m into A. We have to find out acceleration. So acceleration is equal to F upon m. Putting value of F and m, that is 5 by 25. and which is equal to 0.2 meter per second square. Hence, acceleration of the body in SI unit system is 0.2 meter per second square. Then fifth problem. A position of a truck on straight road with time is x of t, means x is a function of t, is equal to 20 plus 30t plus 10t square in meters. When t is in second, find the instantaneous velocities at t is equal to 2 seconds and t is equal to 10 seconds. By the definition of instantaneous velocity, which is equal to the rate of change of displacement, that is equal to dx by dt. As we know value of x, so putting value of x in above equation, we get instantaneous velocity is equal to d by dt of 20 plus 30t plus 10t square. Take derivative of x with respect to t, we get derivative of 20 is 0, derivative of 30t is 30, and derivative of 10t square is 20t. So at t is equal to 2 seconds, let us consider first case. Instantaneous velocity is 30 plus 20 into 2, that is 30 plus 40, which is equal to 70 meter per second. Then consider second case. At t is equal to 10 seconds, instantaneous velocity is equal to 30 plus 20 into 10. 20 into 10 is 200. 200 plus 30 is 230. So instantaneous velocity is 230 meter per second. So in this way, we get the instantaneous velocities at t is equal to 2 seconds. It is equal to 70 meter per second, and for t is equal to 10 seconds, instantaneous velocity is equal to 230 meter per second. Then sixth problem. The position of a particle moving along straight line is x is equal to 7t cube minus 4t square plus 2t plus 6. Find average acceleration between t is equal to 3 seconds and t is equal to 5 seconds. And second one is acceleration at 6 seconds. We know that to find average acceleration, consider instantaneous velocities at that points, and it is given as v is equal to dx by dt. We know value of x, so we get v is equal to d by dt of 7t cube minus 4t square plus 2t plus 6. We get v is equal to 21t square minus 8t plus 2. The instantaneous velocity at t is equal to 3 seconds, means putting value of 3 in above equation, we get v1 is equal to 21 into 3 square minus 8 into 3 plus 2, which is equal to 189 minus 24 plus 2, or v1 is equal to 167 meter per second. Similarly, instantaneous velocity at t is equal to 5 seconds is v2, suppose, which is equal to 21 into 5 square minus 8 into 5 plus 2. Hence 21 into 5 square is 25 minus 8 into 5 plus 2, which is equal to 525 minus 40 plus 2, and the value is 487 meter per second. So we get v1 and V2. Therefore, acceleration. Hence, average acceleration between t1 is equal to 3 seconds and t1 is equal to 5 seconds is v2 minus v1 by t2 minus t1. Putting value of v1, v2, t1 and t2, we get average acceleration is equal to 487 minus 167 by 5 minus 3, which is equal to 320 by 2 or 160 meter per second square. Second case is acceleration at t is equal to 6 seconds. We know that as a is equal to dv by dt, that is acceleration is rate of change of velocity, and we know value of v, that is 21t square minus 8t plus 2. Take derivative of this v with respect to t, we get a is equal to derivative of 21t square is 42t and derivative of 8t is only t. So we get a is equal to 42 into t minus 8. At t is equal to 6 seconds, so we get a is equal to 42 into 6 minus 8, that is 252 minus 8, or acceleration is equal to 244 meter per second square. Problem number 7. A man pulls a suitcase of mass 10.4 kg with a force of 25 Newton inclined to the horizontal at an angle of 30 degree. As a result, the suitcase accelerates horizontally, means along x-axis. What is the magnitude of the acceleration? So given parameters are, a man pulls a suitcase of mass, means m is given, that is 10.4 kg, with a force of 25 Newton, means F is given, inclined at horizontal angle 30 degree, means theta is given 30 degree. The free body diagram will be shown in the figure. This is direction of suitcase, that suitcase accelerates horizontally, means along x-axis. This is a normal force, that is m. This is gravitational force mg or fg, and a man pulls a suitcase of mass 10.4 kg with a force of 25 Newton inclined to the horizontal at an angle of 30 degree. So this is direction of force perpendicular on x-axis. This is angle theta, which is 30 degree. So from figure we get, and we also use Newton's second law of motion. We have to find out magnitude of the acceleration along x-axis. So we consider fx is equal to m into ax, or ax is equal to fx into m, where fx is the x component of force and x component of force from figure is f cos theta. So we can modify this equation, ax is equal to f cos theta by m. We know value of f, theta and m. Substitute here, we get ax is equal to 25 into 0.8660. This is value of cos 30 by 10.4. By calculating this, we get acceleration in x direction is 2.081 meter per second square. Then 8th problem. A 68 kg man is standing on the floor of a lift. Calculate the apparent weight when the lift is at rest. Second case is moving upward with acceleration 1 meter per second square. And third case is lift moves downward with acceleration 2 meter per second square. First consider, we know that when man is standing on the floor of a lift, then there are three situations. First situation is lift is at a rest. Second situation is lift moves upward with some acceleration. And third case is lift moves downward with acceleration. In first case, at rest means there is no acceleration. A is equal to 0. Therefore, apparent weight is equal to only mg. Where m is mass and g is acceleration due to gravity. In SI system, its value is 9.8 meter per second square, and in CJ system, value of g is 980 centimeter per second square. So we get W is equal to 68 into 9.8. Apparent weight is equal to 664.4 Newton. In second case, lift is moving downward with acceleration lift is moving upward with acceleration 1 meter per second square. Means here value of A is given, that is 1 meter per second square. And we know that as lift moves in upward direction, that means upward force will be large than downward force. So the equation is apparent weight is equal to mg plus ma. Taking m common, we get m into g plus a. Putting value of m, g and a. Again value of g is 9.8 meter per second square. M is 68 kg and value of a is given, that is 1 meter per second square. So we get apparent weight is equal to 68 into 10.8, that is 734.4 Newton. And third is the apparent weight when lift is moving downward. Means here downward force will be larger than upward force. Acceleration is given 2 meter per second square. So the equation will be mg minus ma. Taking m common, we get m into g minus a. Again value of m is 68, value of g is 9.8 and a is equal to 2 meter per second square, which is equal to 68 into 7.8 or 530.4 Newton. Then problem 9th. A ship of mass 2 into 10 raised to 7 kg at rest on the surface of the water. On applying a force of 25 into 10 raised to 5 Newton, it is displaced through 25 meter. Calculate the speed of ship after the displacement. Speed of ship means we have to find out V. So first write down the given parameters. Mass of ship is given 2 into 10 raised to 7 kg, which is SI unit. Then force is given 25 into 10 raised to 5 Newton. This is also SI unit. And it is displaced through, means X is given 25 meter. So all parameters are in same unit system. We have to find out V. So for that, again we consider Newton's second law of motion, that is F is equal to ma. First of all we have to find out A and then we can calculate V. Therefore A is equal to F upon m. Value of F 25 into 10 raised to 5. Value of m 2 into 10 raised to 7. So we get A is equal to 12.5 into 10 raised to minus 2 meter per second square. Then from equation of motion, that is v square is equal to u square plus 2ax, where v is final velocity, u is initial velocity, a is acceleration, and x is displacement or distance. But initial velocity u is 0. So we get v square is equal to 2ax, or v is equal to square root 2ax. Putting value of a and x, we get square root 25 into 2 into 12.5 into 10 raised to minus 2. 25 into 2 into 12.5 is 625, and square root of 625 is 25, and square root of 10 raised to minus 2 is 10 raised to minus 1. So we get v is equal to 25 into 10 raised to minus 1 meter per second, that is 2.5 meter per second. So velocity or speed of the ship, that is v is equal to 2.5 meter per second. Problem number 10. The position of a particle along x-axis is given by x is equal to 4 minus 5t plus 10t square. Find the acceleration of the particle at t is equal to 4 seconds. The position of a particle is given, that is x is equal to 4 minus 5t plus 10t square. And we have to find out acceleration. T also given, that is 4 seconds. The velocity along x-axis, that is Vx is equal to dx by dt. Putting value of x, we get d by dt of 4 minus 5t plus 10t square. Means take derivative of x with respect to t, which is equal to minus 5 plus 20t. Derivative of 5t is 5, minus sign as it is. Derivative of 10t square is 20t. So we get Vx is equal to minus 5 plus 20t. The acceleration is Ax, means along x-axis, is equal to dVx by dt. Again acceleration is rate of change of velocity, which is equal to d by dt of minus 5 plus 20t. Again derivative of this Vx with respect to t is derivative of minus 5 is 0 and derivative of 20t is 20. So acceleration of the particle along x-axis, that is Ax, is equal to 20 meter per second square. Thank you.